In the last video, we built the paddle logic, ball counters, and ball motion controls. Today we'll build the bricks and game state controls. For the bricks, we'll need a 7410 in Mary 4, a 7411 in Fox 2, the 82S16 256x1 bipolar RAM in Love 3, and yes, that's 256 bits, 74279 in Fox 7, and 7474s in Easy 6 and Dog 3. We'll also need this 0.1 mic cap on the data in line, the pull-up resistor on data out, and this 1 nanofarad cap on the brick display line. For the RAM, you can use the open collector version of this part, the 82S17 or any compatible part. You do see pull-up resistors soldered from data out to VCC on many boards, so we did a proper site for this. It's meant mostly for open collector chips, but I find that the pull-up makes the brick display better in general, so we'll populate it no matter what chip we put in there. We've got good bricks, and we'll test those as soon as we get the game state controls done. Just like on the breadboard, we'll break up the game state controls into 4 parts: the operational latch, the game start controls, the player up/ball counter, and the serve logic. For the operational latch, we'll need transistors Q1, 2, and 3, diodes CR3, 4, 5, and 7, capacitors C19 and C16, resistors R32, 25, 27, 31, and 26. We're also adding set and reset push buttons, along with the run LED and associated current limiting resistor. Try that out. Well, that latch is not latching. Yeah, inputs to that NAND gate are floating, so the output is keeping the latch in reset. Tie one of those down. Worky, worky. Now we can easily manually set and reset the system run state. Fun stuff. For the start game controls, we'll need a 7402 and Easy 7 and a 7474 and Easy 8. Everything else is already there. Oh yeah, we'll need line pull-ups R57 and R58. We're also adding LED indicators and associated current limiting resistors for a 2-player game, attract mode, and endgame level. We don't have EGL yet, so we need to tie it down to allow us to turn on the op latch. I also tied down the 1 or 2 credit line to fake that out. You can see we're currently in attract mode. Set the operational latch, then press the Start 1-Player Game button. The machine properly comes out of attract mode, so that's working. For the player up ball counter, we'll need a 7408 in Able 4, a 74161 in Baker 4, the 330 picofarad capacitors C37, and a 2x3 pin header for S4. On the legacy board, you can only switch between 3 or 5 balls per play. Just like on the breadboard, we've added a James Bond Balls Forever mode as well. To end a forever game, simply reset the operational latch or remove this jumper when on an odd ball number. We can't make a higher ball count without circuit modification because we're out of counter bits. Nothing else interesting to see here until we've built the serve logic, so let's go there next. We'll need that elusive 7408 in Charlie 1, a 7474 in Able 3, a 7402 in Baker 3, and a few passives. Just like on the breadboard, I had to tie down the FPD lines, otherwise the bricks would not extinguish. Power that up. Looks really good. Still fun to play, even without sound. We'll get sound soon enough. I think that's enough for today. Since everything's working well so far, I'll drop at least a PDF copy of the Rev A schematic on GitHub. Hopefully the rest works. I'll drop the CAM and KiCad project files as soon as we know if we have a good board. In the next video, we'll build a display and add scoring. Thanks for watching.